Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, the Science and Technology channel.
Yep. And today we're talking about a health topic. We've talked about diabetes issues before. This has to do with a different type of treatment, I guess, replacing insulin. So this is kind of eye-opening here.
It's a really interesting way that they're approaching this, really. Okay, for more than a century, people with type 1 diabetes have relied on insulin to survive, but the treatment does not stop the immune system from continuing its attack on the body's insulin-producing cells. Scientists have long searched for ways to address the underlying cause of disease rather than simply managing its symptoms. And engineered stem cell therapy reversed new-onset type 1 diabetes in mice by shifting the immune system away from the attacking insulin-producing cells. Would you like to know more?
Okay. Now, researchers at the Medical University of South Carolina report an experimental stem cell therapy that reversed newly diagnosed type 1 diabetes in a mouse model. The treatment, described in molecular therapy, was designed to reprogram the immune system and protect the insulin-producing cells that remain after disease onset, offering a potential new strategy for combating the autoimmune disorder.
The work was led by Hongjun Wang, a PhD, Associate Director of the South Carolina Clinical and Translational Research Institute Pilot Program, and Co-Scientific Director of the Center for Cellular Therapy. Co-first authors Huo Wei, Junong Kim, all PhDs. When you go,
that's bad. Somebody,
not making that up.
No. Somebody was having fun with that kid.
PhD, together with other collaborators, carried out much of the research behind the findings.
Quote, while insulin injections are life-saving, they cannot stop the immune attacks, and they do not prevent long-term complications, according to Wang. Going on with a quote, the study suggests a new way to treat type 1 diabetes by addressing the root cause, immune system dysfunction, rather than just managing blood sugar, unquote.
The therapy is based on mesenchymal stem stromal cells, MSCs, adult stem cells that can help repair tissue and regulate immune activity. Earlier clinical trials have suggested that standard MSCs may help preserve the insulin production that remains in people with type 1 diabetes. The challenge is that the body's intense inflammatory response can overpower those cells before they're able to reverse established disease.
To make the cells more resilient, Wang's team engineered MSCs to produce alpha-1 antitrypsin, or AAT, a protective protein that helps defend against inflammation. The modified AAT MSCs appear to work in two ways at once, protecting surviving insulin-producing cells in the pancreas, while also reducing the overactive immune attack. Co-senior author Charlie Strange, who doesn't fit into this study at all with those other guys' names,
right?
Medical doctor, emphasized that this combined effect makes AAT MSC treatment more potent than standard stem cell therapy. Okay.
Wang's team next investigated how the treatment was acting inside the immune system. After examining thousands of individual immune cells, they found that AAT MSC infusion did more than quiet an overactive immune response. It appeared to reshape how the immune system behaved.
The therapy affects two opposing immune cell groups. T regulatory cells act as peacekeepers, helping preserve insulin production in the pancreas, while CD8 plus, C as in Charlie, D as in David, 8 plus, killer T cells drive the attack that destroys insulin-producing cells. In type 1 diabetes, the protective cells are present, but they are overwhelmed by a constant wave of attacking cells, which ultimately contributes to the loss of insulin production.
And by the way, we're going to say, blessed are the peacekeepers. Okay?
Yep.
All right. After treatment with AAT MSCs, Wang and her team saw a sharp rise in the number of protective T regulatory cells and a drop in active attacking cells. Those attacker cells appeared to be pushed into exhaustion by the therapy.
Another notable feature of the treatment was its durability. Stem cells disappeared from the body within hours or days, yet the immune system changes continued.
Quote, to impact our cure, type 1 diabetes, the stem cells themselves didn't need to be there, said Wang. This means that when you administer the cell therapy to patients, the effect can last 6 months to 2 years, as seen in clinical trials using MSCs for a range of diseases. Wang thinks AAT MSCs may release microscopic factors that keep protecting organs after the cells themselves are gone.
The study centered on newly diagnosed diabetes, a period when patients are more likely to still have insulin-producing cells that can potentially be saved. The Wang team is now evaluating the safety and effectiveness of MSCs in patients with newly diagnosed type 1 diabetes in a clinical trial. Wang's earlier work in this area was supported by a SCTR discovery grant.
The findings could have relevance beyond diabetes. Wang and her colleagues are already studying whether a similar immune reprogramming approach could be useful for other inflammatory and autoimmune diseases, including lupus and chronic pancreatitis. That is awesome.
Yeah. And this last paragraph is, this should be in almost every one of the things that we talk about, right? More research is still needed, therefore, before this treatment can be advanced into broader clinical testing, but the results point to a possible new direction for diabetes care. So, good deal.
Good deal. Yeah. And if it can help lupus, I mean, a lot of women suffer from lupus. So, yeah, this would be great.
Yeah. Diabetes is it's a tough disease.
I wonder if it would help fibromyalgia.
I don't know. I don't know. Is that kind of linked to lupus?
Kind of, sort of the same effects. I don't know if it's the same symptoms in the body that's doing it, but fibromyalgia, your joints hurt.
A lot of pain.
Yeah, a lot of pain.
Yeah. So, anyway,
right, folks. Thanks for joining us.
Take care, everyone. We'll see you this afternoon.